Hello and welcome to the FactoryTalk Motion Analyzer training. In this session, we will focus on gathering the right data for a correct sizing. After completing the session, you should be able to properly recognize and define motion application objectives and requirements regardless of the application's nature, and also be able to gather all the necessary information for being able to make the sizing and selection that will offer the best value proposition to your customer. When we talk about motion applications, regardless of the kind of application, we often think of a drive module that will drive a motor that will then motor an actuator or tool to do a specific movement to an ultimate goal of processing a final product in a machine or a production line. Now, when we talk about sizing, we need to think in the opposite way. The ultimate goal of the sizing exercise is to select a drive and motor combination and eventual accessories that will match the requirements of the customer's application. This is why our focus in this module is to give you the skills to understand what is important and necessary as in data gathering for sizing for the best possible product selection for each axis of your customer's application. Each application is unique. They may have from one single axis up to several hundreds of axes. Each different axis of the application will have to be sized separately. Regardless of the kind of application and of which axis of the application you're sizing, there are characteristics that fall into a specific section of your sizing procedure that are imposed by the mechanics of your customer's application and also the performance that needs to be achieved by this axis in the application context. These characteristics are divided into these sections: global variables, axis type, load, and mechanics. All of these are used as inputs into our sizing software, FactoryTalk Motion Analyzer. Throughout this training module, we will be using as a reference our sizing tool, FactoryTalk Motion Analyzer. Here you can see that for sizing an axis in FTMA, the process starts from the load side, goes through the motion profile definition, and through the mechanics until we get to actually choose the motor and the drive that we need. Temperature and altitude are taken into consideration for the rating and for the thermal models of the motors and drives. They are input at the Project Preferences section of your project. The mains power voltage is also determinant of the drive and motor that can be chosen. This information must be defined at an early stage of the project, but will be input to FTMA at a later stage of the sizing process in the step where you get to determine the drive for your axis. The axis type defines if the movement of your load is either rotary, like in a winder or unwinder application, or it is a linear displacement. A linear axis implies the use of a linear motor or a mechanism that transforms rotary into linear movement, like a lead screw. It is also important to know if the linear movement is done horizontally or if it is inclined or vertical because of the effect of the gravity in these cases. In FTMA, the axis type is chosen in the Setup tab, and the orientation for linear axes is done in the following step in the Profile editor. The load is what is effectively being moved by the actuator. If it is a linear axis, we will consider the load mass and any external force being applied to the load. Equivalently, for a rotary axis, the load will have an inertia and may have some external torque being applied to it. In FTMA, these data are input at the motion profile configuration page for each segment of the motion profile. Additionally, if friction is involved, a friction coefficient for linear axis and a friction torque for rotary axis can be input as well. The motion profile is the axis movement pattern. Normally, the axes have a cyclic repetitive behavior. In FTMA, the motion profile is designed in the Profile Editor section. It is composed of one or more segments that reflect the actual movement that the axis physically does. The motion profile must contain the most demanding movements that the axis is supposed to make. That means that the movements with steeper acceleration or deceleration changes. That often happens when the machine or line is at full speed production. It's also important to include the dwell times when the axis is standstill in between movements for intermittent movement axes, because FactoryTalk Motion Analyzer considers the motion profile as cyclic. So if the dwell time is not included, it will affect the heat capacity estimation of the system. More on how to use FTMA and the profile editor will be covered on upcoming modules of this training. Finally, the mechanics are basically everything in between the load and the shaft of the motor. That varies from axis to axis, and they can contain none, one, or more than one of each of the following: mechanisms, transmissions, and gearboxes. Each of these topics will be covered in detail in an upcoming module of this training. Once you have all the data related to the load, motion profile, and mechanics, you are finally ready to look for the best motor and drive combination for your axis. You should now be able to recognize and define motion application objectives and requirements and know what is the important information to gather from your customers. You have now completed this motion analyzer training module. Thank you for watching.